Okay, this is the objective on students will be able to factor a polynomial using the GCF. Okay, get that down. Alright, I'm going to move on. If you're not quite done, go ahead and hit pause and finish writing. Okay, factor. That word was in the objective. This is the first time we're really going to work on factoring. This is the start of it all. Okay, so we know what factors are, but let's review it real quick. So let's write down factoring. Obviously, it's related to factors. Okay, factoring is when you write answer as the product. Okay, it's when you write your answer as the product of two or more terms. Okay, and a key with this, a key is answer, your answer. Oops, typo there. Your answer must be multiplication. Okay, your answer must be multiplication. Alright, let's go through, again, if you're not done with this, hit pause, finish writing it down before you go on to the next slide with me. Okay, so let's talk, let's keep it simple first. Let's think about if we factor 10. Okay, there are two ways that we can write 10, basically factor 10. Okay, one way is it's just 2 times 5, right? We know that 2 times 5 will get us back to our original 10. Okay, another way that we could write this would be 2 parentheses 5. Okay, essentially we just factored 10. With the special products of binomials, we sometimes saw, and if you haven't seen this you will, okay, a form of like, we might start with like n squared minus 24n plus 144. Okay, and we could rewrite that as, okay, so this is the factored form, let's write factored form above it. Okay, the factored form of that may look something like this, where it's n minus 12 and n minus 12. And again, if you haven't done this yet, we're going to get to it in the next few objectives. Okay, how do we know that this is the factored form? Because it's the product. Okay, it is the product of, we can just say product of, let's just say 2 things for right now. Okay, we're multiplying 2 things together. And if we multiply these 2 binomials, okay, and we'd use the box method to do it, it would get us back to this original, this is a trinomial over here. Okay, again, if we multiplied this, it would get us back to this form right here. That's how we know it's factored. Okay, let's just dig right in and let's start. We just have to do a few of these and you'll see. Now the awesome thing about this objective is all we're really doing is combining the last 2 objectives that we've already done. So if you can find the greatest common factor of a trinomial or a polynomial, you're in great shape. And then if you can divide, you're in great shape. You're going to do awesome on this objective. So it's really important that you master the previous 2 before you attempt this one. So let's do example 1. The directions may say something like factor, let's just write it out, negative 8x squared plus 12x to the 4th plus 18x, let's do x squared, and let's do y to the 3rd. Okay, so it'll say factor this using the GCF. Okay, that's what the directions would say. Okay, the first thing that we have to do, okay, the very first thing, if we're going to use the GCF, is the first thing that we have to do is find GCF. Okay, that's the very first thing that we have to do. And remember, to find the GCF, we've already done this, but to find the GCF of that entire expression, okay, we first need to find the GCF of the numbers, okay, and then we need to find the GCF of the variables. Okay, so if we look at the GCF of 8, 12, and 18. Okay, in the previous objective I showed you how we can use a factor tree to find the GCF, but we also know that we can find the GCF of anything using factor cows. Okay, so we can just put 8 in here. And for the GCF of the numbers, we can just ignore the signs for now. Okay, so we're going to find the GCF using factor cows. So the next one is 12, and the next one, you don't have to be fancy with your cows, clearly. Yours are probably a lot better looking than mine. Alright, so all the factors, remember we can do the square root of 8 and find out we have 1 and 8. We have 2 and 4. Okay, that's it for those. For 12, we have 1 and 12. We have 2 and 6. And we have 3 and 4. Okay, for 18, we have 1 and 18. We have 2 and 9. We have 3 and 6. Okay, so now remember we need to find the greatest common factor. So here's how I do this quickly. I always look for the greatest. Okay, the greatest one over here is 18. Do they all have 18 in common? And the answer is no. None of the other ones do. Okay, what's the next greatest one? Oh, there's 12 right here. Okay, do they all have a 12? The answer, clearly no. Again, I'm looking for the greatest. The next greatest I see is 9. They don't all have 9. No. Next greatest is 8 over here. Do they all have an 8 in common? No. Okay, then I'm looking at the next greatest, it looks like is 6. Do they all have a 6 in common? Well, this one has a 6, this one has a 6, but this one doesn't. Okay, so no. Let's see, what's next? 4. Do they each have a 4 in common? Well, this one does and this one does, but this one does not have a 4, so it's not common. And next is 3. This one has, the first one doesn't have a 3, so nope. And again, I'm showing you the long way to find the GCF of these numbers if you couldn't just do it in your head, but it's really important that you can find the correct GCF. Okay, next I have is 2, and they all do have a 2. Okay, so the GCF of the numbers is going to be 2. Okay. Next, I have to find the GCF of the variables. Okay, so step number 2. You guys should have a lot more room in your notes, but I'm going to squeeze it in. We need to find the GCF of variables. Okay. Now, how do we find the GCF of the variables? We look at which variable or variables do they all have in common. So if we look at all 3 terms, again these are 3 kind of terms here. This first term has an x, second one has an x, third one has an x. Okay, so I know that my GCF is going to be x, and now I have to figure out what power it is. And remember, our smart cut is we just take the lowest power, okay? And the lowest power is on this first and second one, so it's going to be x squared. Essentially, we're saying this first term has 2 x's. This second term has at least 2 x's, it has 4, and this third term here has 2 x's. Now, this y, is y part of the GCF? Okay, the answer is no, because this first and second term, they don't have a y. Okay, so our GCF of this entire expression here would be 2x squared. Okay, again, the GCF is 2x squared. Okay. Now, with factoring, so step 1, again, when it says to factor using the GCF, first thing we have to do is find the GCF. Okay. Now that we found the GCF, and I'm going to start a new page, so I'm going to rewrite the original problem, which was negative 8x squared plus 12x to the 4th plus 18x squared y to the third. Okay. Step 1 was find the GCF. Step 2 that we're going to do, so 1 was find the GCF of the numbers, 2 is find the GCF of the variables. Step 3 that we're going to do is simply divide out. And I'm going to write it over here. So kind of step 3 is divide out. Divide out GCF. Okay. This is something that we have already done. So the GCF that we said, again, separate the terms. Okay, the GCF that we already said was 2x squared. Okay, so underneath each of these, I'm going to write 2x squared. Okay, factoring, I want you guys, when you think about factoring, to think about this. Think about factoring as pulling out of each term that 2x squared. Okay, and by pulling out, we mean division. Okay, so if we divide this first term by 2x squared, we're going to end up with a, well, negative 8 divided by 2 would be negative 4. Okay, x squared divided by x squared, we subtract the exponents, they cancel. The next term, 12 divided by 2 would be a positive 6, so plus 6. And then x to the fourth divided by x squared, we subtract the exponent, so it would be x to the second power. And then this next one, 18 divided by 2, would be 9, a positive 9. Okay, and then x squared over x squared, they cancel. And what's left? That y to the third. Okay, I'll give you a second to get that down. Okay, now, it is absolutely imperative, okay, that when you do this, you cannot just forget about this GCF here. We pulled it out, but we don't want to change the actual value of the answer. Okay, so the next thing that we have to do, okay, the step 4 that we have to do is rewrite with GCF in front of, let's just show parentheses. Okay, so that GCF right here, 2x squared, we need to show in front of, okay, the parentheses. And here's all we're doing when we factored. All we're doing is rewriting it differently. Remember, factoring is the product of basically two things. Okay, right here, it's touching, right? So it's a product. So we're saying that if we multiply, let me change colors here. We're saying that if we multiply this 2x squared times each of these terms inside, what do you think is going to happen? And you guys don't have to write this because I'm just kind of explaining what we did. That right there is your answer. Okay, but if we multiplied this 2x squared by each of those terms, what do you think would happen? Well, it would get us back to this original problem. And that's what factoring is, right? When we wrote out 10 and we said, oh, well, we could rewrite that as 2 times 5, okay? Did we actually change the value of what our expression is? No. This side is 10 and this side is 10, right? We didn't change the value, we just wrote it differently, okay? You're factoring using the GCF. Okay, should look like this. You should have the GCF, and you guys should write this. You should have the GCF on the outside, and then the factored polynomial in the parentheses. Okay, so that's how it should look. Now, another thing with this is that we want to, and let's write this key point, and I'll explain to you why it's so important in a second, is we want to always check to make sure each term does not have another GCF. Okay, want to make sure each term does not have another GCF. And again, I'll show you what we mean by that in the next example. Get that down. If you're not done writing it, go ahead and hit pause, finish writing it, and then you can move on to the next slide. Okay, let's do example 2. I'll give you a second to get this down. Again, make sure you write the instructions as well. Okay, let's get started. I'm going to actually make a mistake on this, and I want to show you what can happen if you do make this mistake. Okay, so the first step that I need to do is find the GCF of the numbers. Okay, so I'm going to do this in my head, and I'm going to say, oh, the GCF of 12 and 28 is 2. Okay, so again, why don't you guys just actually go ahead and write this down, and then at the end we'll correct it, okay, because I want you guys to see this mistake as well. So let's just say that I think it's 2. Okay, and then the GCF of the variables is, well, they both have an x, so I can say x, and then I just take the smallest exponent, so it would be 2x to the third power. Okay, the next step then, once I have that, is I need to factor out, or basically pull out that GCF of each term. And right away, what I like to do is, before I go any further, I'm going to kind of write the answer, the most common mistake. And I want you to write this. Don't forget, the most common mistake, okay, is to forget to write that GCF out in front. So then I'm going to divide out or factor out this GCF of each term. Okay, so 12 divided by 2 is 6. The x's basically cancel because 3 minus 3 is x to the 0 power. Anything to the 0 power is just 1. Minus 28 divided by 2 is 14. X to the 5th minus x to the 5 minus 3 would be x squared. Okay, so if I look at this, I say, okay, cool, I'm done. I just factored it, right? Because if I actually multiply these two back together, use the distributive property, I would get back to my original problem. Okay, and you're right, you would. But here's the problem. The way we did this, and I should say I, not you, I didn't find the GCF, and here's how I know. Okay, if you look at both the 6 and the 14, do they have any other common factors? And the answer to this is yes. You could still factor out a 2 out of each one of those. Okay, so I want you to write this. Still have common factor of 2, which means our mistake was that we did not find greatest. We did not find the greatest common factor. We found a common factor, but not the greatest common factor. Okay, so let's actually correct our work on this. I'm just going to start a new page. 12x. Okay, so this is that same problem. Now we're going to do it correctly. The GCF should be instead, it should be 4x to the third power. Okay, so I'm going to write that. Okay, and if I divide out that 4x to the third power, should separate my terms. Again, if you're still struggling on finding GCF, you really need to practice that because that is one of the toughest parts of this objective. Okay, 12 divided by 4 is 3. The x's cancel, so I have 3 minus because a negative here divided by the positive 4. 28 divided by 4 is 7. And then x to the 5th divided by x to the 3rd, we subtract the exponent, so it would be x squared. Okay. Now that I look at this, now that I look at this 3 and 7, do they have any common factors? And the answer is no. Okay. Does this have an x in it? No. There's nothing common to each of these terms. That's what we want, because otherwise we didn't factor it all away. Okay. Now to check this, let's check it. So to check it, let's just show the work. 4x to the third power. And then we had 3 minus 7x squared. Okay, to check it, we can just distribute. When we distribute, we end up with 12x to the third power minus 28, 28x to the, when we multiply, we add the exponents. Okay, does this get us back to our original? And the answer is yes, it's the same. Okay, so that's how we know. So our answer to this one would be this right here. That's our factored form using the GCF. Okay, let's do another example together. Okay, let's look at example 3 problem here. It would say something like factor, and it's not always going to say factor using the GCF. You're eventually, when we get into the other objectives, you'll learn this, but eventually you're going to have to just learn, oh, this is a type of problem where I can factor using the GCF. Okay. All right, so first thing I need to do is look at factoring using, find the greatest common factor of the numbers. Okay, so if I look at this one, the first number that comes to my mind would be 7. Okay, so that just pops in my head. But I also want to check 14 could also be a factor. So my question is, does 14, what I'm thinking is 14 go into 49 evenly? So you can do 49 divided by 14, or you can just do like 14 plus 14 would be what, 28, plus another 14 would be 32, 42. So no, 49 or 14 will not go into 49 evenly. So therefore the GCF of the numbers would be 7. Okay, and I'm actually going to write that a little bit lower, because I'm just going to start writing out my answer form, right? Whatever that GCF is, I'm going to write it outside. So I'm just going to start writing my answer format. Okay, so it'd be 7. And then let's see, look at the variables. So the first variable I see here is x. Does each term have an x in it? And the answer is no, because this middle term doesn't have an x, right? It only has a y. Okay, so x isn't common to all of these terms. And then let's look at y. So this term, the second term and the third term have a y, but does the first term have a y? And the answer is no. So on this problem, there are no common variables to each term that we could factor out. So our GCF in this case, kind of a weird one, but our GCF in this case is just the number 7. So all we're going to do out of each one of these terms is factor out or pull out the 7. Okay? So a negative 14 divided by positive 7 would be 2. And clearly we're not doing anything with the variables because we didn't factor them out. So the variables actually just stay. Negative divided by a positive would be a negative, so it's minus. 49 divided by 7 would be 7. Keep that y to the third because I'm not pulling any y's out. And then this positive 14 divided by the positive 7 would be 2. And then I just keep the variables, 2x squared y. Okay. So I think we'll stop there for example problems. I'll probably post a worksheet online where before class you need to do those worksheet problems. I'll post the answers right there. You need to check your answers, and any mistakes that you're making, you need to spend the time trying to figure out those mistakes before you get to class. And if you have questions, obviously write those down on paper so that when you get to class you remember exactly what your questions were.